This is the exercises video for lesson 3.3, which had graphs of trigonometric functions, and also we had some fundamental trig identities. So the exercises I will work are here. They come from OpenStax Precalculus 2E. I recommend you try them, then you can come back to this video where we will go over the full solutions. These four here from textbook section 6.1 have to do with the graphs of the trigonometric functions, but all four of these have to do with the graph of the sine. And I have included it here. If you recall from our lesson, this function is periodic with period 2 pi. And if you go from 0 to 2 pi, the sine goes 0, high, 0, low, 0, and sits between -1 and 1. Okay, so we begin with 31. On 0 to 2 pi, solve f of x is 0. Well, it's open. You notice this is open, so we are not including here, but we can see the function is 0 here at 0 and pi. We can see this looking at a graph. Now the last one, on 0 to 2 pi, once again, we are looking closed and then open on this side. Solve f of x equals a half. Well, here, halfway in between is about here. You can see there will be two values, but we're not going to be able to just read it immediately off a graph. We have to go back and think about the unit circle and think about reference angles. So if my unit circle is here, we're going to have one answer in quadrant 1 and one answer in quadrant 2. In fact, you can see it right here. We will have one answer between 0 and pi over 2. We will have another between pi over 2 and pi. But the sine being a half, this says the reference angle is pi over 6. Pi over 6 is where the sine is a half, cosine is square root 3 over 2. And so one answer would be pi over 6 exactly. But the other one, let's see, let me sketch my two here. One is here, pi over 6, and one is here with a reference angle, pi over 6. So the other one would be pi minus pi over 6, which is 5 pi over 6. So this will be my other answer here. We have two of them. This is the answer to 32, and this is the answer to 31. Now, we're still considering f of x as the sine of x. On 0 to 2 pi, open at 2 pi, what the maximum value of the function occurs at what x value? And then the next question is about minimum value. Well, we can go back and look at the graph. That's one way to attack this. You see the maximum value the sine takes is 1, and the minimum value the sine takes is -1. So this occurs at pi over 2. So let's just write the full thing. We have a maximum value of, it's y equals 1, and this occurs at x equals pi over 2. And then here we have a minimum value. Well, the smallest the sine can be is -1. And this occurs at, well, we saw it in the graph. It's right here at x equals 3 pi over 2. You could also just think about the unit circle. It will be down here, 3 pi over 2, where the sine is -1. So this occurs at x equals 3 pi over 2. So the question is asking what x value. So this is what I will underline here and here. Now we move on. Those were our few questions about graphs. We move on. The next section is about simplifying expressions using the fundamental trig identities that we discussed. And here's our first one. We have sine times cosine times secant. This one is kind of on the short side compared to some we will do, but we can write secant as 1 over cosine. So now we have sine times cosine times 1 over cosine, and this simplifies to the sine. This is our answer for this first one. Now let's do some more. We have tangent times the sine plus secant times cosine squared. I think the easiest way to get started is break everything into sines and cosines. So let's begin this way. Tangent is sine over cosine. And then this other sine is in the numerator. So I can do it like this. And then secant is 1 over cosine. So I have a cosine squared in the numerator. And then in the denominator, I have a cosine. But now you see, I have the same denominator. So I could just call this cosine, but then I wouldn't be able to add these two terms. Written like this, you see I have the exact same denominator. And so I can add, I have something all over the cosine. And you notice I have sine squared plus cosine squared. Sine squared plus cosine squared is 1. Most important trig identity. And so we just get 1 over the cosine. This simplifies to the secant. Now the next two, we want to verify an identity. Okay, the best way to go about this is you want to start with either the left-hand side or the right-hand side. Use trigonometric identities until you arrive at the other one. So I'll just start with the left-hand side, and then I should arrive at the right-hand side. That would be my verification. So the left-hand side, you see I have cosine x minus cosine cubed x. And the first thing I realize, I can factor out a cosine. So I have cosine x, and then I have 1 minus cosine squared. Well, if you recall, and we did this in the lesson, but it's wonderful to remind ourselves, you see, we know that sine squared plus cosine squared equals 1. And so I see a 1 minus cosine squared here, and I can get that from this. Just subtract cosine squared from both sides. And so I have sine squared x equals 1 minus cosine squared x. This is what I'm going to do in my next step. So then I have cosine x times, well, 1 minus cosine squared is sine squared. And now you see, we have verified because this is the right-hand side. So we can just put a check mark. We're finished with this one. This was our verification of this identity. Now, next one, once again, I'm going to start with the left-hand side. So the left-hand side looks like this. In this case, I'm going to multiply everything out, but you have to be careful because you cannot just distribute the squared across a parentheses. It does not work like this. Really, maybe I'll even do this in 2 steps. This is sine x plus cosine x times sine x plus cosine x. Now you can see I have some things to multiply out. The first gives me sine squared. The outer gives me sine cosine. The inner gives me cosine sine. And then the last gives me cosine squared. Well, we are almost at where we want to be for the right-hand side of this identity because look, sine squared plus cosine squared. This is 1. In fact, I'll also underline this in green highlighter. And then the other, you see, sine times cosine is the same thing as cosine times sine because you can multiply in any order. And so I'm left with 2 sine x cosine x. And this is the right-hand side of this identity. So we have verified. The next 2 are prove or disprove. So maybe these are identities, maybe they are not. We will go about them in the exact same way that we went about problems 29 and 32. But if we cannot arrive at the right-hand side through trigonometric identities, then we would be disproving. So we can begin with 35. Let's see, I have some choices here. I could break everything into sines and cosines. This is always a possibility for us. However, I see cotangents and cosecant squares, and that's making me think of something we talked about in the lesson. So let's just talk about that for a moment. What did we talk about in the lesson? Well, generally, we have talked about multiple times that sine squared plus cosine squared is 1. And I can get 2 other identities from this. One is an identity involving secants and tangents. That's not what I'm looking at here, but the other is an identity involving cosecants and cotangents, and I see those here in this prove or disprove. And so let's see what the correct identity is that involves cosecants and cotangents and squares. How I would get that from this is just divide every single term by sine squared. So let's do that now. We have sine squared over sine squared. Then we have cosine squared x over sine squared x. And then finally, we would have equals 1 over sine squared x. And now we see the correct identity. We see that 1 plus the cotangent squared equals cosecant squared. So this is a true identity. So back to the problem, let's just copy the left-hand side. We have cosecant squared, and then we have 1 plus sine squared, okay? And this equals, well, let's distribute. This would be cosecant squared, and then plus, well, when I multiply cosecant squared, I can write it this way, sine squared, and cosecant squared is this. So we get cosecant squared x plus 1. The question becomes, is this the cotangent squared? Well, this is an identity we know holds. We have derived it from sine squared plus cosine squared is 1. So we see what the cosecant squared is. Cosecant squared is 1 plus cotangent squared. And now I have another 1. So without a doubt, this is not equal to cotangent squared. So this one says that the given identity at the top does not hold. This one was a disprove. I like this example because it makes us go back to this original identity and remember what the right one is, involving cosecant squared and cotangent squared. And well, this does not follow from it. Now, let's move on to the next one, prove or disprove, number 41. Is it the case that this equals this? Once again, let's start with the right-hand side. We have 3 sine squared theta plus 4 cosine squared theta. And you see, I can break off 3 of the cosine squared. So let's do that now. We have 3 sine squared theta plus 3 cosine squared theta plus 1 more cosine squared theta. Now this looks really nice. So let's factor out a 3. We have sine squared theta plus cosine squared theta. And I still have this cosine squared theta. But now you see sine squared plus cosine squared is 1. So we're left with 3 plus cosine squared theta. So this one, I will copy and paste, but change it. You see, we have verified. So the given identity in this question does hold. We have proved this identity. We can put a check mark. This one does hold. So I can emphasize this part does not hold, and here does hold. One identity we proved and one identity we disproved, both of them using our fundamental identities for trigonometric functions. So this is the end of the exercises for lesson 3.3. Thank you so much.